2.8 talks about related rates. If A and C are the area and circumference of a circle respectively with radius r, find the A dt and the C dt in terms of the r dt. So if I look at an area is pi times the radius squared. If I take d dt of both sides, I will get the change of area with respect to time. Pi is a constant. You're going to bring the power down, subtract 1 from the power, times the derivative of the inside. So that's how those two are related. And if they ever ask about the circumference, is 2 pi r, and if you take a derivative, two pi is a constant, and that will be the r dt. And that's basically it. By the way, just saying, this is not a coincidence. If you take a derivative of volume, you will get the surface area. Alright, well, there it is. Now what? Suppose a rock falls into a pond and creating circular patterns. So you drop one rock in a pond and start making those, ripples. They're circular. If the radius of the pattern increases, that's the r dt. If the radius increases at 3 feet per second, how fast are the area and circumference? How fast are the area and circumference, I think that's spelled correctly, of the pattern increasing when the radius is 17 feet? Well, let's go for area. For area, we're going to say the A dt equals 3 and r equals 17 feet. So the change in the area of that would be 2 pi, it's right there, times the radius times 3. And what are the units for area? Well, if you multiply those units, or simply area is in square feet and time is in seconds. And there it is. You could multiply that for the homework. No need to worry about that for the test. And if they say how fast is the circumference, well, there's the circumference. The circumference is changing at a rate of 2 pi. It's independent of the radius. So that's 6 pi, and circumference is in feet per second. That's kind of like the perimeter, but it's not a polygon, so we give it a special name of circumference. Second problem. To find the area of a triangle given a triangle, any triangle. If I told you this side is A, this side is B, and the angle is included in there. So, the area of a triangle with sides A and B and the angle theta is the angle between the two sides is given by, this is the area. The area is 1/2 A times B times the sine. I could derive that, but that's trig. Part A says if A equal 3 and B equal 4, then those are fixed. Area is 1/2 3 times 4 the sine of theta, or area is, that's 6 the sine of theta. If those are fixed, and theta is increasing at a rate of 1 radian per minute, 1/2 radian per minute. How fast is the area increasing when theta equal pi over 6? Well, the A dt would be 6 the cosine of theta d theta dt. And wouldn't that be 6 times the cosine of pi over 6 is radical 3 over 2. D theta dt is 1/2. And what are the units for area? Well, this is in centimeters squared per minute. Again, I'm going to leave the answers are exact. For the homework, you can plug that in the calculator or simplify. For the exam, just leave it as is. And here they go back to the same equation. They say, hey, if A equals 3 and B is increasing, so A equals 3 and B is, so the change of B with respect to time is 2.5 centimeters per minute, and the change in theta with respect to time is still 0.5 radians per minute. How fast is the area changing? dA dt equal what when B equal 5 centimeters and theta equal pi over 6? Well, now, out of those, I know that area is 1/2, A is 3, B is varying, times the sine of theta. So that's the equation now. dA dt would be 3/2, you ignore the product rule. Derivative of the first times the second, plus the first times derivative of the second. And if I substitute everything that I know, that will be 3/2 times the change of B with respect to 2, that's 2 with respect to T, that is 2.5 or 5/2. Sine of pi over 6 is 1/2, plus B they told us is 5. Cosine of pi over 6 is radical 3 over 2, and the theta dt is changing at a rate of 1/2. What are the units for area? Centimeters squared per minute. There it is. Again, we could multiply those. That's not that bad at all. I'm going to just do that really quick right here. That is 5/4 plus 5 radical 3 over 4. So that is 15, factor of 5 out, 15 over 8 into 1 plus radical 3. There. All of these are saying the same thing. You distribute that, you don't, it doesn't matter. On a test, I want the units and I want the answer. Exact is fine. And then the last part says, what if A is increasing at a rate of 5/2 centimeters per minute, and B is increasing at a rate of 1.5 centimeters per minute, and theta is increasing at a rate of 1/2 radians per minute. How fast is the area changing? Well, what's the ADT? And it has to be when what? Specifically when A equal 2, B equal 5, both of those are in centimeters, and theta equal pi over 6. Well, in this case, it's going to be a bit longer. Area equal 1/2 AB, the sine of theta. The change of A with respect to T is going to be the 1/2. I'm going to treat that as 1 and that as 1. Derivative of the first times the second. That's the product rule. That's the A dt times B plus A times dB dt plus AB times the derivative of the second, which is cosine of theta d theta dt. Now you would figure this out quickly. If you didn't really get implicit out of the way, you're going to be very confused on all of these different implicit differentiations. Well, the A dt is given to be 5/2 times B. B happened to be a 5 plus A happened to be a 2. dB dt is 3/2 plus, times the sine, messed up, times the sine of pi over 6 is 1/2. So that plus doesn't fit there. Plus A times B, that is 2 times 5. The cosine, which is radical 3 over 2, and the theta dt, which we said was 1/2. The units for area are centimeters squared per minute. Again, You could clean that up. You could leave it as is. For the homework, I want you to clean it up. So that is 1/2 times 25 over 2 plus 3, or 6/2 I should say, multiplied by 1/2, right? Plus that mess is 5 radical 3 over 2. So this is 41 over 2. That is 1/2 times 41 over 4 plus 5. Again, there's no point in doing all of this work for no reason, you know. But if you want to match it with the back of the book, all over 8, all over 8, that's going to be 41 plus 10 radical 3. Multiply this by 2 top and bottom, and distribute that to 1. There it is. But this is good enough. The next problem, if a large air balloon is leaking air so that its surface area is decreasing at a rate of 1/2 centimeter squared per minute. So you have one of those awesome things. You have a sphere. You know, something like that. It's leaking air out. Find the rate at which the diameter decreases when the diameter is 6 inches. Okay, diameter is twice the radius. So I know the surface area for a sphere is 4 pi r squared. So for the test, any figure that's not a prism, I'll provide the formulas. Well, this is the surface area. Well, what's ds dt? That is, actually before I do that, I have two options. Actually, yeah, that's fine. I could. I could say S equal 4 pi times, and what does the radius equal? Isn't that the diameter divided by 2? So wouldn't you say S equal, that is 4 pi d squared over 4, isn't that pi r squared, pi d squared? And if I take a derivative, ds dt is going to be, bring the power down, twice pi d, the change of the diameter with respect to t. Well, this is negative 1/2. And the diameter is 6 centimeters. And I'm looking for dd dt. Well, dd dt would be simply multiply both sides by 1 over that. That would be negative 1 divided by 2 times all of this, times 2 pi times 6. Okay, I'm not sure what's happening, but there. Ooh, too many of these lines. So 1/2 you multiply by 2 pi times 6. So I could say that change of d with respect to t is negative 1 over 24 pi. What would be the diameter? That's in centimeters, and the time is in minutes. So as you see, the setup is the most crucial part. We're going to take a derivative every time, no questions asked. Okay, at 1 o'clock, ship A is 100 miles west of ship B. At 1 o'clock, ship A is 100 miles west of ship B. Ship A is sailing east at a rate of 40 miles per hour and ship B is sailing south. So, okay, at 1 o'clock, ship A, ship B. Ship A is 100 miles away from B. This is at 1. Ship A is sailing east at a rate of, if I call this the XDT, is actually 40 miles per hour. Ship B is sailing south. If I call this Y, the YDT is actually 25 miles per hour. How fast is the distance between the two ships changing? Call this S. They're asking the SDT equal 1 to 3 in 2 hours. And let's see how this works. Okay, well, if I call this distance X, then wouldn't this be 100 minus X? And how are those related? Well, if I look at this triangle, because remember those moved, I'll get 100 minus x squared plus y squared equals s squared. And there's a shortcut to do these problems I'm going to show you really quick. That's okay. So if I take a derivative with respect to t, bring the power down, times negative dx dt plus 2y dy dt equals 2s ds dt. The 2's cancel out. I'm looking at 100 minus times negative plus y dy dt equals s times ds dt. So let's figure out what all of those are. Let's see. In 2 hour time, my triangle looks like this is x, this is 100 minus x, but this is traveling at 40 miles per hour. So in 2 hour time it covered 80. That makes this a 20. And this is traveling south at a rate of 25 miles per hour. In 2 hours, that's 50. Right? So this right here would be the square root of 400 plus 2500. So that would be the square root of 2900. What is that? That's s. S is the square root of 2900. Alright. X is we said 80 miles. Or we could say this distance is 20, whatever you like. But the fact I have it here, the x dt is traveling at 40 miles per hour. Y we said was 50. And dy dt is 25 miles per hour. All what I have to do, divide both sides by the square root of 2900. There's my answer. What are the units for the SDT? Well, S is going to be in miles. Per hour. And that would be my answer.